Something wrong with my earphones. Some message is coming here.
I will start, madam.
Sir?
Start.
Okay, sir. Is it voice is audible, Arti?
Yes, madam.
Okay. Good afternoon to all the dignitaries and participants. I am Dr. M. Kalpana Devi, Associate Professor, MCA Department. So it is my pleasure to welcome you to this Day 2 Faculty Development Program on Recent Trends in Computer Science, organized by CSE Department in association with the MCA Department, Srinivasa Institute of Technology and Management Studies. So today's resource person is Dr. K. Sangeeta ma'am. I am very much delighted to introduce you, ma'am. She is working in Kongu Engineering College located in Perundurai in Erode district, Tamil Nadu. She has 17 years of teaching experience. Her area of specialization is mobile ad hoc networks. She has published more than 20 international journal papers, among those 10 Scopus publications. She have 25 national and international conference papers. She organized more than 20 national seminars and workshop on latex and 5 national conferences. And also she organized 2 IoT workshops with IIT Bombay. She presented 18 invited talks and she is currently guiding 3 PhD scholars. So we are very glad to invite you, ma'am. Now I request Dr. K. Sangeeta ma'am to take over the session.
Thank you, ma'am. Good afternoon to all the dignitaries live on the session and the dear participants. I'm happy to associate with this 5 days FDP program organized by Srinivasa Institute, Sittur. I'm very delighted to join this 2 days session, and I thank the organizers and the management for giving an opportunity during this great learning time. I'm very delighted to have the session on NS2, which is my area of interest. Here under the NS2, we will be dealing with 2 day sessions. The first day I will be giving an overview of NS2 and the heterogeneous network. And the second day we will be getting into the heterogeneous network and how NS2 is deployed for the network. Okay. So now I will share the screen. Hope the screen is shared.
Okay, ma'am.
Okay, I will start the presentation. Hope the screen is visible, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Screen is
Okay,
visible.
I'm audible also.
Yes.
Okay. So, getting into the today's session topic, I will be concentrating on the network simulator overview. Okay. So the today's agenda, first I will give over the today's agenda. So this is the today's agenda. We will be go through the overview of NS2 and little bit how the NS2 was started and what are the platforms it is supported and what is the other simulators available. I will give you a list of simulators that are available, and we are often go through this NS3 along with this NS2, how NS2 is different from NS3, the overview we can see, and the basic features of NS2, how it is a discrete event simulator, that concept, and what is the NS2 environment and the different hierarchy of protocols that are supported under NS2, and getting into the NS2 architecture, how we have to build a simulation architecture, how the node architecture is developed, how the nodes multicasting is supported, what is the packet structure that is supported under NS2, and what is the link structure, and how the traffic is flowing over under NS2 environment. All these things we can see, and I will show a small illustration video of wired as well as wireless network, and a small overview of a heterogeneous network, and how hands-on can be done over with the NS2 for a heterogeneous platform. We can also go through a glimpse, we can go through. Okay. So basically NS2 is a simulation environment. So why do we go for a simulation? Is real-time experiments cannot be done over. Okay, with the great building up of a network and all, it is not at all possible. Okay, if you are developing a very big network like wireless sensor network for measuring the temperatures in a forestry or underwater network we are developing, so it becomes very costly. So to overcome that cost effectiveness, we are getting into this simulation. We are overviewing how the different protocols are working over under the simulation environment, and then we are trying over under the real time. Okay, so if it is working good under the simulation environment, then it can be supported for the real environment also, and it is best suited than the mathematical model analysis also, because if you are going for the research under the network environment, if it is simulation means we can done it over easily. The pros are lot under the simulation environment. But if we go for the mathematical analysis or the real-time setup, it is very difficult. Mathematical insight should be there for the researcher. That is a great problem nowadays. And the real-time environment setup is also a cost effectiveness wise, it is difficult. So we go for the network simulation, where we simulate a environment of network and go through how it is working and how the protocols are running over there in the environment. We can go through, and then based upon that we can go for the building up of the real-time environment and deployment of the real-time protocols under that environment. So the simulation is a first step for the analysis of the protocols that we are developing. So it's a very great supportive platform. Once we know the program, a basic programming of any simulation tool, it would be easy for us to do the analysis. Okay. So this is the overview of NS2. Lot of versions of NS2 are available. Why this name NS2 means, here the version, second version of NS2 is very famous and it is very supportive. You have lot of versions like NS 2.2735, like that, lot of versions with different modules added out. Okay, so because of that famousness, it is called as NS2, Network Simulation 2, version 2. And NS3 is totally different. The language itself different from NS2. It is not a next version of NS2. Okay, it is totally a different simulation environment. Okay. So getting over the NS2, it's a discrete event simulator. So the simulation running above the environment is done over in a small pieces of packets. Event wise it is generated and the simulation is carried out. So you have the packet level analysis of the different environment protocols. So you can model the different network protocols also under the NS2. This is the great help of your NS2 environment. So you have collection of various protocols in your environment. So these are the different protocols. You have the TCP, you have also the UDP supported here. The different versions of TCPs. You know that TCP/IP is a family of protocols, suite of protocols. So these are the different versions of TCPs that are supported. And you have the MAC layers, the different MAC layers, 802.11, 802.3, like your TDMA, access, all this can be supported. And you have the ad hoc routing supported, like your DSDV, DSR, AODV, TORA. These are the 4 important protocols supported under NS2. They are already built in under NS2 environment. Okay, so you know what is ad hoc routing. So ad hoc routing is environment in which the nodes are not dependent upon any infrastructure. The nodes that is in the network device is called as a node. Okay, so the nodes themselves act as a routers and they connect with the devices in their vicinity who are in the transmission range. With them, the nodes connect themselves. So it is ad hoc routing. All of a sudden, you are forming a network and you are transferring the data. So it is an ad hoc routing. Then comes the development from the wireless network itself. It is also a type of wireless network. So in this, you have a variation, that is the sensor network. Okay, wireless sensor network. So that can also be deployed and that can also be simulated using NS2. Okay. So where you have the sensors, small sensors developed in this network for reading out different values, sensing out different values and giving over to the environment. Okay. So you have, other than this, you have multicasting protocols, you have the satellite protocols even, and many other protocols, even for your VANET, that is vehicular ad hoc network, where you have the vehicle to vehicle communication, that can also be deployed with this NS2. Okay. So it is an environment for evaluating how the network protocol is working, how the network performance is there. So it's a great environment for analyzing the network. So it's a great project. NS2 is a great project developed by this WINT project, and it has been given out freely as an open source and distributed widely. And you have the support of this NT Research Lab, and it is used also for the education purpose also. And it provides a very common reference and an interface very supportive for many of the languages like your C++, your Perl, and even awk scripts can be included under NS2. It's a very supportive environment. So it is a very old language. Okay, so it was developed by this Lawrence Berkeley's lab. Under this lab, it was developed, and lot of versions were evolving year by year. Lot of versions with the new modules were evolving for supporting the satellite models, for supporting the wireless models. The lot of versions of NS2 were evolving, and it's a very supportive simulation environment, supporting both the Unix version as well as the Windows version. Okay, you can install NS2 under Unix, different Unix platforms as well as the different Windows platform, all the versions it supports. And lot of simulation environments are there. The one that is comparable with NS2, often compared with NS2, is NS3. Okay, so that only I have given over the comparison of NS2 with this NS3. So we have the other commercial simulation environments like your ORMnet, QualNet. Okay, the different commercial environments for simulating the wired as well as the wireless network is also available. But NS2 and NS3 are very open source and very compatible with almost all the platforms. Okay, so but they are totally different. NS2 is a different environment and NS3 is a different environment. So both of them can run over wired as well as wireless simulation, but NS3 is most suitable for the internet simulation. Okay. So when compared to NS3, you have the backward compatibility in NS2. It is very much supported under NS2 because it is running over with two languages. That is, NS2 is running over with two languages, C++ as well as tool command language. Okay, so it's a very unfamiliar language for the students' perspective. It is a very unfamiliar language, tool command language. It is a small scripting language like your JavaScript and other thing, which doesn't have more syntax and other things. Okay? It's a very easy to learn scripting language. The front end of NS2 is developed with the TCL, and the back end coding is concentrated with the C++. But under NS3, you have only the C++ running. It is totally written in C++, and it is supporting the C++ environment. And sometimes nowadays you have the different versions where the Python programming is also included as an interface for NS3. Okay, so which is not supported under NS2. Okay, so we have the NS3 for solving out some of the small problems that are prevalent in NS2. So what are the problems that are not sorted out under NS2 means you have only 4 protocols supported under NS2. DSDV, DSR, TORA, you have this AODV. So these protocols are alone supported, and the rest of the other protocols we have to include them under NS2 as a patch. As a patch files we have to include, but this supports lot of protocols. That's the main difference. And we can include lot of codings, okay, under NS2, which is very limited under NS3. Okay, so NS2 is basically a bi-language system supported with C++ and TCL, but NS3 relies only on C++. If you know C++, you can do with NS3. Okay, but the coding part is very much limited. Okay, it is not as extensive as NS2. Lot of packages are available under NS2, but it is not there under NS3. Mainly if you go for an emulation environment, okay, where you want to include some hardware also under your simulation, okay, during that time you can go for the NS3. So it is very suitable for the real-time networks NS3, and this is NS2 is only for the simulation, that is only for analyzing how the environment is. For that alone you can use, but the extensive packages available under NS2 is not there in NS3. So these are the comparison that we can do with the NS3 about NS2. So these are the different components that are supported under NS2. So you have the NS, the simulator environment, which is a very important component. And then you have the network animator, which is used for visualizing our simulation environment. Okay, whatever simulation we are doing, all those simulation can be visualized using this NAM platform, network animator platform. It is also a supporting tool coming under NS2. And other than this, you have the supporting for drawing the graph. You have X graph also under the environment. So it's a very great supportive tool for analysis purpose. If you want to draw some graphs of our output, we can draw the thing. And then what are the pre-processing and post-processing we do under NS2? So here you have the pre-processing, that is we will be writing some handwritten scripts, that is we will be coding some TCL scripts, and then we will be running out our simulation environment. Then you will be generating the topology with that TCL script. After generating the topology, we will be going on with the simulation, and afterwards we will be analyzing the simulation with the Perl, TCL, awk, or even with MATLAB. So these are the post-analysis we will be doing. Once the simulation is over, we will be analyzing the simulation. The trace files would be generated and we will be analyzing it with this software. How our network is behaving, whether the protocol is good for our network, the new protocol we have designed is good, whether the packet delivery ratio is good, whether the jitter is less, okay? Like that, we will be analyzing what are the overheads that we are facing. All this parameter analysis we will be doing under the post-analysis. Okay? So these are the components that are present, and from the user's perspective, we will be knowing out how the NS2 is behaving. Okay? It is a simple object-oriented tool command language. Why it is called as object-oriented tool command language device means, software means. So it is supported with the C++ as well as with the tool command language integrated with the object concept. Okay. So because of that, we call this software as OTCL supported interpreter. Okay, so it's an interpreter based. The front end, the OTCL is interpreter based, and the backend libraries that is running over for the different network components is compiler based, since it is running over on the C++, based upon the C++. So what we will be doing as a user when we install the NS2, what we will be doing means we will be developing some OTCL scripts. Okay, so this script is used for generating the topology, how our network should be, how many nodes should be there, how many links should be there, what protocol we should be running over. All those things we will be specifying under our script, and that script would be run under the NS2 environment, which would be taken care by these two interpreters, this OTCL interpreter as well as C++ libraries. A great vast hierarchy of libraries you have under NS2 for supporting the network environment. So with this, you will be getting out the output. Okay, the output will be a NAM output where you can visualize how your OTCL script is running. The visualization you can view as a NAM output, animation output, or you can view it as a trace file, text file output also. With that trace file only, you are going to analyze. With this trace file only, we are going to analyze how our network is. What is the packet delivery ratio? What is the throughput? All those parameters we are going to analyze. How we are going to analyze? With the help of the different small scripting languages. And mainly Awk is a scripting language supported, well supported under NS2. Okay, so this is the way in which as a user of NS2 we visualize NS2 in this way. So hope I'm audible and getting the concepts. Okay.
Yes, madam.
Okay, thank you, sir. So we have seen NS2 as a discrete event simulator. Okay, so it is not a continuously it is not sending out the packets. Okay, it is sending out the packets in a small event packets. Okay, so the packets are given out as a small event from node 1 to node 2. Some of the event would be triggered out, and that makes the packet to run out to node 2. Okay, so during the time we will be consciously noting down the time also. So it is event based and as well as time based also. We will be noting down what are the events, and we will be queuing all the events, and they will be scheduled one by one. So you have a scheduler taking care of the different events. After this event, what is the thing that must happen? Okay, after this event 2, what is the thing? The next event 3. So it gives over the scheduler gives over the handles, that is the pointers from one event to another event. Okay, so event by event, as you have designed the simulation, event by event, it would be running over. Okay, so for example, if I am starting out an event at 1.5 millisecond, okay, at this time, and sending a packet from node 1 means it would be traveling. Okay, and imagine these two nodes are connected, and it would be traveling, and it would be reaching. Say it reaches at 1.7 second, and again it receives the information, and it wants to send back. The second node also wants to send back some information at 1.8 second. Let it be the acknowledgement or any other packet. Okay, so it is a duplex link. So what is a duplex link? Two-way communication can be taking place from this node to the next node. Between 1 and 2, the communication can take place. Okay, so it receives the packet. The one receives the packet at this second, 2.0 second it receives. So like this, the events are queued and processed in a proper order, and you can schedule them based upon some priority also. Priority based queues are also that. So this is the detail about the discrete event scheduler. So which is a very important data structure supported under our S2. Okay. So here it is a data structure with all these components. That is, you have a head. Okay, under this Q data structure, you have one particular pointer called as head. And if you want some event to be inserted, you can insert it, and that handle would be taken care with the handle function. Okay, so with the help of the handle function, it is taken care and it is triggered out one by one from based upon what time and what is the ID of that event and what is the handler, next handler, and what is the handler function. All this based upon this, the events are taken care under this scheduler. So it's a very important data structure. So whatever event, that is whatever action we want to do under the simulation, it is all stored as events under this scheduler, and it triggers out one by one based upon the time that we have scheduled them. If I want, for example, in the previous case, if I want the packet to be sent at 2.0 second, means I have to schedule the event here at 2.0 second. The time and all I have to schedule here. Okay. And after that event, what is the next event that we have to handle, and what is the handler function? Okay. So the handler invokes this handle function. Okay. So based upon this, the events would be triggered out one by one and it would be taken care. So this is a very important event scheduler. So here you have a lot of event schedulers. Among this, you have the list, heap, calendar. Based upon the applications, we can go for the different kinds of schedulers. If it is a non-real-time application, means you can go for this one. And if it is a real-time application, means we have to go for some specialized simulator dealing with the emulation part also. Okay, so basically an event scheduler takes care of the simulation events. So what is the next action that must be taken place in a simulation? Okay, so when this application should start, when it is going to finish, okay, what are the packets that must travel, all those things must be scheduled under this event scheduler. So based upon the different kinds of environment that is we are working with, you can go for the different event schedulers. So here you have NS2 environment, which we have been discussing over. For example, we have the simulation scenario, developing the node 1 and 2 connected via a link. This one we just now saw. And for that, at the back end, for this scenario, what is the TCL script we will be developing? So with the script only, we will be noting down the simulation. So we will be schedule the simulator and we will be setting out 2 nodes under the node class. Okay, so these are the different classes available under the NS2 environment. The simulator class, you create an object. For the node class, you create an object node 0. Okay, so this is, let it be node 0, and let this be node 1. Okay, so like this we will be scheduling out the TCL script like this. And if essential, some implementations we want to do with at the back end, means we will be writing out some classes, C++ classes and those functions and all we will be writing over. So like this only you have the NS2 environment. At the front, you will be visualizing the NAM output the back for the NAM output, you have to develop the TCL script. It would be supported with the help of your C++ implementations. Okay, so this is the NS2 environment. So moving over. So we have the next concept, the TCL interpreter. What are the different interpreters that are available under our NS2? Okay, you have the OTCL, object-oriented support of tool command language, and you have the C++ also. The C++ and the OTCL are connected via an interface called as TCL-CL. Okay, so this is a great interface. We have to transfer just a minute. We have to transfer the data from the C++ to OTCL, and we have to transfer the data from the OTCL to C++. So for that, you have the linkage, the interface, the great interface, that is your TCL-CL. Okay, so TCL, the OTCL, the interface, the event scheduler, and the different network components, the C++ libraries, everything combined to form the NS2 environment. Okay, so it is a discrete event scheduler. It is not continuously sending out the events. It is taken care by a small data structure called as a scheduler. So this is the hierarchy of classes that are available. The basic TCL object you have, and you have this NS object. So this is object, NS object class you have. From that you have the classifier taking care of the nodes, and you have the connectors, the different agents, UDP agents, the applications, what is the queue, what are the different types of trace files we will be dealing, and if there is any delay in the transfer of packets, how it must be dealt over. For all these things, you have the classes. For this class, we have to create an object and take over under the scripting. Okay, so these are all predefined classes. And other than this, you have a great hierarchy of classes. Under the agent, you have variety of agents. That is the two varieties, UDP and the TCP, are the most used varieties. And other than that, for your ad hoc routing, you have this distance vector routing, DSGV, and you have this ad hoc on-demand distance vector routing. Then you have the TORA for dealing over the energy-wise packet transfer, and then you have the DSR. So this is especially for your wireless environment. Okay, and you have this variety of TCPs. In the wired environment, you may not known with this all this TCPs. We will be getting over with the different family of TCPs here. Okay, and then you have the different variety of applications that can be supported here. You can develop a basic constant bit rate application, or you can go for telnet remote login application, or you can go for monitoring the internet traffic. For that you can develop applications, or you can go for dealing over exponential packets. Like this, you can go for FTP. Different applications you can develop, and all these things are classes. Okay, so for them you have to develop an object and get into the coding. And you have variety of queues, each one characterized with their own characters. For example, this drop tail queue is the most often used queue structure. Okay, So it is used for taking over the different packets that are dropped over when we are transferring the packets from one end to another end. Okay, so it is having a variety of queue structured classes also. And if we create an object for this queue structure dropped in, then we can use them in our coding. So all this library are predefined under NS2. C++ library of classes are available. So for dealing over the different trays of packet, you have NQ class, the packets that are being entering the queue, it is called as NQ. The packets that are being coming out of the queue, that you call it as DQ, and the packets that are being dropped out. For dealing with all these things, you have the different set of classes under the trace class, basic class. So like this, you have the NS2 directory structure also, the different simulation class. Under that, you have the different folders. If you open the NS2 all-in-one directory, when you are installing the NS2, you will be getting this NS all-in-one directory. Under that, if you open the sim folder, you will be go through all these folders. Okay, so under which the NS2 is the very important folder, under which you have the TCL and the set of examples and some of the test classes and the libraries, and you have the NAM folder for running out the NAM environment also. So this is the basic NS2 directory structure supported. So NS2, we will deal with the C++ coding. Here we will be dealing with the TCL coding and the different library codes, and the different validations can be done over under the test folder. Of course, the small library set is also available. So here we have the node architecture of NS2. So how a node is defined. Okay, so here when any packet comes here into the node, it is given over to the classifier. So you have two types of classifiers, address classifier and the port classifier. As we will be dealing with the port for taking over the different applications, and address classifier for dealing over the links. To which application? Suppose I am running over the FDP. So the which port I have to give over, and which agent, routing agent, the packet has to be taken over. And if I am going on with the address classifier, here I have to deal over to which link I have to hand it over, so that it is going to that appropriate address. All these two things it has to take care under the node. So the classifier data structure of the node will be taking care and segregating your packets accordingly and giving it to your different agents. Okay, so this is the great architecture of your node. So here the agents or the protocols are the related objects for taking over the packet feeds. You may have the UDPs, you may have the TCP, different versions you can have over and take over. So mainly the classifiers demultiplex your packets based upon the port number and based upon the address that is mentioned in the packet. Okay. So this is how multicast node architecture is designed. So when we get into the greater research concept of NS2, we will be getting into the multicast node. So it has to deal over with a great environment where the multicast classifiers are included, and they take care of to which group, multicast group, the packet should be forwarded, whether it should go to the group 1 or whether it should go to the group 2. So based upon that, the agents and the links would be taken care. Here also you have the port numbers, and here also you have the address classifiers. So it's a great environment. And this is the basic packet structure. Any packet, it has to deal with this three things, that is the next handle. Okay, it is a pointer taking over the next packet that should be given over after this packet, then what data it can access, and what are the bits of information that it is transferring. It is taken care by these two functions. Okay, so here size is determined at the compile time, how much bits of information it is transferring, and then you have the TCP header taking care of the things again, and you have the different IP headers also taking care of the things, and you also have the trace headers, like that you have the MAC headers, like the different variety of headers taking care of the bits of data that is being transferred via the packet. Okay. So this is a small information about the packet structure. And this is a very important thing. Once you have the two nodes and they are connected, if it is a wired network, okay, they are connected via a link. Okay, so if it is a wireless, they are connected under the transmission range. If two nodes are coming under the transmission range, they will be transferring the data. But if it is a wired environment, here the link is very important. Okay, so how the packet is getting into the link, so that you have the NQ trace acting, and then you have the queue structure. The packets are coming and getting into the queue, and if the queue is okay, it would be there, and if it want to send to the other side, it would be dequeued. Okay, so it would be dequeued and coming out, that is coming out of the queue, that if there is any delay, what is the TTL, time to live, okay, all those things would be noted and given back. But if the queue is overwhelming, it is not able to deal with the packets are continuously coming over, means the drop head would be noting down the packets that are being dropped from the queue, and that would be noted down with the help of the class drop trace. Okay, so like this, if it is a wired network, means you have this link. So it's a very important concept of wired environment, which we develop using a NS2. So the basic way how a packet is transferred between the two nodes N1 and N2, suppose these two nodes are connected. Okay, so via a link, if they are connected. So this is the node structure which we have seen just now, and this is the node structure of N2, and they have a link. This is the link structure. So how the packets are transferred from one end to another end. So here an application would be running, and that application would be carrying the data. Yes, here you have the application that is running both the sides. Some application is running. So this application would be generating the data and giving over the data to the agent, and this agent would be carrying the data, classifying the data, and giving over to the link, and it would be going to the, via the link, it would be going to this node, and again it would be classified and given to this agent, and it would be from the agent, it would be given to the application. So that is what given over here. The packet is generated, it is going via the link. Okay, it is classified and it is given to the agent, taken by that agent and given to the application. From this application, again some data is coming, so it is a bi-directional link. So it is a bidirectional link, duplex link. Okay, if it is a simplex, one directional means it would be a simplex. Only one link would be there. It is a bidirectional link. It is a duplex link. It is called as duplex in NS2. If it is one direction means it is called as simplex in NS2. So like this, the simulation environment is working. Packet transfer takes place. Okay, so it's a very clear generating the data and giving over the data. Okay, so like this only. Okay. So coming over to the features of NS2, just now we saw that it is a supporting two languages, C++ and OTCL. With the C++, we can create lot of objects for improving our speed and efficiency of our network. And with the OTCL, we can develop the topology for which network, for the wired network, for the wireless network, or in the wireless itself, MANET, WANET, okay, wireless sensor network, okay, for which network we want to develop the topology. All those things we can concentrate via the OTCL. And then why two languages are supported in under NS2? So this environment is very supportive for the programming. C++ environment is very supportive for the programming. And when you go on with the TCL, it is very supportive for developing the simulation environment. Okay, so with this two only, we are going on hands for the development of our simulation environment. Okay, we can go for the exploration of different simulation environment, number of scenarios with the help of the TCL. Okay, so wired, wireless, wirelessly, you have variations, lot of things you can do. And backend coding can be supported with this C++. Okay, so this is the strength of NS2, which is not there in NS3. Okay, so here we can take off the different debugging concept also under NS2 with the help of C++. So this is the simple thing, the features of TCL and C++, the configuration for network configuration, for the network setup, for the different scenarios, we need the TCL. And for the internal processing of the packets, the behavior of the network, that is being decided by the C++, what coding we do. And we know that C++ and OTCL have to be linked, okay, between each other for the transfer of data. Okay, so for transferring the data, you have the TCL-CL, the interface. Okay, so the different interfacing functions support the transfer of data from the hierarchy of OTCL classes to the C++ classes. Okay, so how the hierarchy works, okay, between the OTCL and the C++, that is being given over in this slide. So here you have the agents, the different routing protocols, they invoking the parent classes, and then with the parent classes constructors, you create the C++ objects and give over to the C++ objects from the TCL and give over to the TCL interface, TCL-CL interface. With that one, the C++ environment takes care of the agent functions, and with that one, it takes care of the final output. And if it wants to give over something, again, you can use intern. It uses its own function from the C++ to the TCL. you have the functions, these functions acting over. You have the bind function, very important function for binding the C++ objects and your TCL objects. Okay, so it's a very important TCL-CL interface function, and the init function for getting over the transfer of data complete. So like this, you have the different C++ objects. What you have to do, we have to write the C++ coding, and if you are newly adding the coding, we will be going on with the makefile and then recompiling it. And if you are doing some thing under the existing protocol itself, we will be recompiling the coding, just the thing. Okay. So these are the things we do. And for the installation, if we go for the installation of NS2, we go on with this packages. For example, under 2.27 package, you have these small components as a package coming over, NS2 all-in-one, it would be coming over. And you can install it, install the package, and you have to set over the paths and validate all the packets, and it would be working. So these are the generic steps that we have to do for scripting over the NS2 coding. So first thing, we have to create the simulator environment. And what does this turn on tracing means? Here we will be turning on the tracing for the packets as well as for animation. Two types of tracing we will be doing. One is NAM tracing and the other is packet level tracing. NAM tracing is only for visualization, while the packet tracing is for analyzing the packets, which is very helpful for an network analysis purpose. Okay, so packet tracing only we will be dealing. NAM tracing only for visualizing the output. Okay, then we will be going for the topology. Under the topology, we will be designing how many nodes, what is the link, what is the agent, what are the applications, all those things we will be taking care. And then we will be going for if any packet loss is there, link dynamics, we have to set over, all those things we will be dealing. And the next important concept is creating the routing agent. So here we will be designing whether we go for the UDP agent or whether we go for the TCP agent. And then for the application, which kind of application, FTP application or CBR application, for that we will be creating the objects. Once everything is done, we will be running out the simulation, and the NAM output will be visualizing, and we will be starting the simulation, and then we will be going on for the post processing, where we will be analyzing the simulation output. Okay, so these are the general steps, and for that you have the scripts for the simple topology, which I will just show you with a small illustration. So this is the NAM output. So like this, you will be coding out the TCL scripting, and the NAM output we will be getting out will be just like this. These are the nodes. Okay, it just looks like a multimedia application. Okay, the NAM output, and this is a very important thing, that is the time will be running over, and this is the time scale, and you can speed out the simulation, you can slow down the simulation by adjusting this bar. Okay, and these are the nodes that are designed over for the scripting. For example, this is node 0 and this is node 1, and from node 0 some packets are being transferred and some packets are coming over as acknowledgements, like that. Okay, so this is the environment. So this is the overview of our NS2 environment. Just now we saw, that is, we will be developing the OTCL scripts. Okay, And with the scripts, we will be having what is the node, what is the environment, what is the link setup, what is the agent used, what is the application, when the event is triggering. Okay, all those things we will be giving under the script, OTCL script, and we will be saving the script under the name .tcl. Okay, and we will be running this TCL under the simulation environment, ns file name.tcl, like that we will be running it under the environment. So once we are running, we will be getting two types of output. Okay, so the first output will be a NAM output with which the NAM file would be generated. Okay, so with which we can visualize the animation. Just now we saw the animation, no? Like this, the nodes animation would be popping out. So it is an animation output. How the network that we have designed is looking like. It would be giving over. And then the next output is the trace file output, which is very essential for any program analyzer, network analyzer. So this trace file output would be in the form of text file. A lengthy of records would be there. For the wired network, you have a trace file output. For the wireless network, you have a trace file output. Okay, a different format would be that. So based upon that format, using these scripts, any one of the scripts, you can take the awk script, you can take the Python coding, or you C++ coding, or the Perl coding. With that programs, you can analyze the trace file. Okay, how many number of packets have been dropped out, how many number of packets have been received. Based upon that, you can calculate the throughput. Okay, all these things, parameters, network analysis parameters, you can measure with the awk scripts. And then with the awk script results, you can give over the result to the XGraph, which is a supportive tool under NS2, and you can plot the graphs for your network purpose. Okay, so this is the general working structure of NS2. So which we have discussed till now. And the small example coding I will illustrate. Okay, so the simulation I will show you. I have my NS2 under the Ubuntu platform. I can't switch over to the Ubuntu platform just now since I am in Windows. Okay, so I'm recorded the session, my running over session, and I'm giving over the thing. So here I have my desktop, Ubuntu desktop, where I have my NS2 all-in-one platform, and I'm opened the terminal. So under this terminal, I'm giving over the ls command, the list command, to list over the things that are present in that folder, and I'm getting into my folder. This is how the NS all-in-one package would be looking like. I'm getting into this folder. I have my 2.35 version. I'm getting into this folder, and I'm listing out what are the things that are present. These are some of the folders, and I'm getting into this npm folder where I have the small wired example. So cd npm, I have get into the folder. I'm just giving over the clear command so that you can visualize how I am running over the TCL script. So here I have an example under this folder, wired.tcl, an illustration of wired NS2 simulation. So how I am running over the thing, ns wire.tcl. If I am giving that one, the NAM output is popping out. So this is the NAM window that is popping out. So you would have seen it, what I have given. So this is the play button, pass button, like that you have the thing. and here the simulation running time, and you can forward and move forward and slow down the simulation. So here I have 4 nodes which are connected, and here I have the time scale. So based upon the simulation running, the times would be running, the scale would be running. So I have given the play. So the time scale is moving, and also the time, you can visualize that one also. Time is also forwarded. So it is a time based, and here at this time, the node 0 is transferring the packet to node 3. Okay, I can slow down the simulation also. So I'm slowing down the simulation. And if I want, I can fast forward it also. So again, from node 1 also, the packets are being transferred, and it is more, some of the packets are dropped out here. So this is a wired environment where we simulate 4 nodes which are connected to each other, and from this node an application is running and transferring the packets, and from this node an application is running and transferring the packets via this node. So for this we have done the coding, the TCL's coding under the environment. So once the simulation is over, everything would be stopped, and it would be, the simulation would be winded out. Okay, so like this, we have an illustration for the wired network, and similarly I will show you the coding also. I will, after visualizing the wireless environment, so I will now illustrate the wireless environment also. I have the illustration for 2 nodes, as well as in the same thing itself I have illustrated for the multiple nodes, generation of multiple nodes under the wireless environment. So here, under the wireless environment, the nodes would be transferring the packets when they come into the vicinity. If the transmission range is what we have set out in the coding, based upon that, they would be transferring the data. If they are moving apart, they won't be in the vicinity, and they won't be able to transfer the packets. Okay, so like this, you can visualize the illustration. So I have a folder again in my desktop, a wireless folder. I'm getting into that wireless folder, where in the desktop, so I'm getting into the desktop, and then the wireless folder, I'm getting into it. There I have my file, wireless 2 nodes. For that I have wireless 2.tcl. So this is how, just a minute, this is how you have to run the TCL file. Okay, so ns wireless, the file name .tcl. Okay, and then the simulation is over, and I'm visualizing for NAM output. I'm visualizing running out the NAM. So here I have 2 nodes. And the 2 nodes I am playing out. I'm playing out the simulation. The simulation is running. And I'm fast forwarding the simulation also. The time scale here you can visualize, it is also running. So here you can see the packet transfer. Okay, packet transfer. It is a UDP packet transferred. So it is just coming over as a dot. I haven't given any colors also. Everything you can give, the shape, color of the nodes, everything you can define over. The next simulation is for multiple nodes, where I run over the next file. This one again with 20 nodes. Okay, the number of nodes is here is 20. Okay, and I again run over the NAM file. Okay, the output is stored in NAM, so I am running it as NAM file name.NAM, and the NAM window is popped out with multiple 20 nodes. The same NAM coming out with 20 nodes now. Okay, so I am giving over the play. So here you can visualize the different nodes, and I have given a little bit mobility of the nodes also. They are not organized. Okay, so we can organize them under different clusters. Okay, that is different groups. And for the clusters, you can make a cluster head. All these things we can do under NS2. Okay, so the simulation time I'm forwarding, so that you can the scale you can visualize. So here the nodes you can visualize little bit, they are moving. Okay, and you can give the colors and the different pattern recognitions. All those things you can give over. So basically this simulation is only for the understanding purpose. Okay, so how the network is behaving. Okay, so for that we are able to understand how the network is behaving in a different environment. Okay, so like this we have the environment. So then the last part, the small overview of the heterogeneous network, that is where we are dealing out. We have the wired network, we have the wireless network. What is this heterogeneous network? Here the nodes may be wired or wireless. They are having the different operating systems, the different configuration systems, and they have to get connected in a network. Okay, so we have them as nodes formed with different kinds of, that is, sorry, network formed with different kinds of nodes configuration, that we call it as heterogeneous. So in this group you have the different nodes. Okay, you can find out the different nodes, this one and all same, this one and all different, like that. Okay, so you can take this best example where you have the 4 nodes. Okay, these 4 nodes are coming under the different 4 nodes, means you can have them as the people with 4 devices, laptops, PDAs, iPads. Okay, some mobile. Okay, they are getting into this conference, and with this they are getting into the conference. So they may have the iPad person and the laptop person with the windows. They have to interact in this conference, so they form a heterogeneous network here. And again here with this 4 persons, we have the different groups. They may be colleagues, they may be friends, like that. The different pattern of groups we have, and they may be connected in LinkedIn, or they may be connected in Facebook, like that. Different networks they may be connected. Okay, so during that time they should be supportive. Your device should be supportive for getting into the different network. Even if you are having an Apple device, and even if you are having a Windows device, your friend is having your Windows device, you should be able to get into the network. Okay, so this is dealing with the heterogeneous network. So this is a network connecting computers and other devices where the OS and the protocols has significant differences. And the best example, when we deal with the local area networks with Windows and an Apple system, how they are getting connected. And when we deal with the wireless technology, the wireless LAN formed with the different devices, and we are switching over from one device to another device network. For example, I may be connected in 3G now. Later on, my network is going down, means I may be going to some other network for getting over the 4G. Okay, so totally different. So that must be supported. Access technologies must be supported, which is a heterogeneous system access. So with this, we have the today's session winding up with a small introduction about NS2 and what for the NS2 is used and how the heterogeneous system is developed. Okay, so with this I given a small overview of NS2 here, where we are getting into the simulation environment for our networks. And so any queries, ma'am? I have taken 10 more minutes.
Okay, ma'am, it is an excellent session, ma'am. Thank you. You have given a very clear explanation regarding overview of Network Simulator 2 and what are the platforms that are supported and the comparison. So you have given comparison between NS2 with NS3 and many concepts. We have learned today a lot, ma'am, regarding NS2 environment, and you have given some examples, that is coding, shown simulation as recorded video also. So it is for wired and wireless. It was very useful for us to view, and I have given some overview about heterogeneous network, and it was very nice session, ma'am. Thank you, ma'am. Thank you very much. Dear participants, so if you have any doubts or queries, so you can post in chat box so that ma'am will answer.
Dear participant, do you have any query? Please raise your hands here. We'll unmute. We will unmute.
Okay. You can directly interact with ma'am. Raise your hand so that we will unmute.
Any queries from YouTube, madam? Aarti, madam, you check it out.
Yes, sir. Checking in YouTube, I didn't get any queries, sir. I'm checking the chat box again.
Okay.
All positive comments only, sir.
That comments okay, but queries.
No queries.
No.
Participants, you can post your queries either in YouTube chat box or in Zoom. Ma'am will answer for your queries.
I've got a query from Jeevita R.
Okay, ma'am.
Okay, so what is the latest version of NS2 and will it work on Windows 10? Yes, it works on all versions of Windows from 98 to all XP, all Windows 10 till all the versions we have. And you have the latest version is the thing that evolved in 2001 is the latest version, that is 2.35, and you have the 2.37 for supporting the satellite networks. Okay, so that is the latest version. Other than that, you don't have any improvements in under NS2. With that itself, it is more than enough for developing even a satellite network. You can simulate and see. So you can see the extensive power of NS2. The mobile network, everything you can simulate and see.
So participants, any queries? Raise your hands so that you can interact with directly.
Ma'am, what is the difference between NS2 and NS3, ma'am?
So I've just shown you in the PPT. I will share the PPT also. It's a very simple mark. NS2 is environment that is supported for wired and wireless environment. The coding part of NS2 is very vast. It supports with two languages, that is C++ and OTCL. But NS3 is running over in only C++, and it is supportive for the real-time simulations. Internet packet and all you want to simulate and see means for those real-time simulations, you want to directly get into the internet and connect and see how the network is working. Means you can go for NS3, and it is suitable for the basic wired and wireless also. But the thing is, the coding part of NS2 is not that. That is the library part of your NS2 is not there in your NS3. That's the main difference.
Okay, ma'am.
Angita, Jivita, unmute your mic and ask the questions.
Jeevita.
Yes, sir. Yes, ma'am. I have asked the question, ma'am. That's there in the chat box, and ma'am has replied.
Okay.
Okay.
Thank you.
Thank you, ma'am.
Ma'am, one more doubt, ma'am.
Yes, ma'am.
Ma'am, what is the major difference between QualNet and NS2, ma'am? For research purpose, which one will be better, QualNet or NS2?
Yes. Coming to QualNet, QualNet is proprietary, ma. We have under our TBI, Technology Business Incubator at Kongi Engineering College, we have the QualNet version 2, but it is proprietary. It is a little bit costly. Some 5 years back, we afforded it for some 7 lakhs something. And the same thing, it is very user friendly. QualNet is user friendly. Here, we are coding with the OTCL, but that we will be coding everything with the backend coding alone. You have to do. We can. It is user friendly. That is Windows like drag and drop. All those things would be there under QualNet. It is user friendly, but for research purpose, if we go for the research purpose, it is a little bit costlier. It is working similar to NS2 only, but little bit costlier. Why? Because we have to afford each of the module with a price tag. If you want to simulate a wireless sensor network, you have to buy a package. Okay, like that it is costly. Other than that, it is user friendly. But other than that, both of them are same. Backend coding we have to do. Okay.
Thank you, ma'am. Thank you, ma'am.
Any other queries
Hello.
from participants? No, madam. Kalpana, madam. You conclude, madam.
Okay, ma'am. So it was nice, ma'am. Dear participants, so you can have tomorrow's session also by Dr. Sangeeta, ma'am, and you can enjoy the session.
Thank you, sir. Thank you, ma'am. And tomorrow I will handle a little bit extensively about development of heterogeneous network with the NS2. That is wireless sensor network. I will take a case study and illustrate. It would be very interesting.
Ma'am, one query from the participant side, ma'am. If you don't mind, can we ask?
Yes, ma'am.
Can we have 30 to 90 nodes at the same time?
Yes, of course, hundreds of nodes we can have. But the thing is, when we go for some 200 or 250 nodes, the simulation time would be taking a lot. Okay, that simulation time would be overwhelming, and it would be little bit slowing down your system. That's the thing. Other than that, the results and all would you would be getting it perfect. For the research purpose, we will be comparing 50 nodes with 100 nodes. Okay, all those things we will be doing. So when we go for more number of nodes, the simulation time would be taking a lot. That's the thing.
Okay, ma'am. Thank you, ma'am.
Okay, ma'am.
Participants, the feedback link have been posted in chat. So in Zoom, who are attending in Zoom, you can see it in chat. Those who are attending through YouTube, there also we have posted the day 2 feedback form. Kindly check it and fill it off. Any other queries from participant side or Shall we continue tomorrow? Participants, if you have any queries.
No, I think no. We conclude.
Yes,
From
sir.
we conclude.
Okay, sir. So thank you for all organizers, for that is convener of this FDP program. And today we will conclude session. Thank you one and all.
Thank you, madam.
Yes, sir. Thank you, sir.